Good morning, everyone. I welcome you all to the Anand Sagar College of Engineering, Department of Management Studies, online finance lecture series on the subject financial derivatives. And we were currently in module 3 on options contracts, where today the main objectives of this session will be to discuss on the problems related to European call and put options using the Black-Scholes model and the problems on put-call parity relationships. Now consider the first problem. The current stock price of Reliance Industries Limited is found to be 1,500. The European call option with the exercise price is 1,400 and it will expire in 90 days. The annual yield on the 90-day treasury bill is given as 88% and the standard deviation which is associated with the underlying stock is 60%. Find the value of the call as well as the put option. The various steps that will be followed in order to find out the value of the call as well as the put option is described as shown below. So first one is we have to note down what all things have been given. The second step is first find out the probabilities which is associated with the spot price as well as the exercise price. So first we'll find out the value of D1, then D2. Then we will find out the probabilities which are associated, that is ND1 and ND2 from the cumulative normal distribution tables. And then we will find out the value of the call option as well as the value of the put option. Remember, the put option value can be found out by using the formula from the Black-Scholes model or by using the put-call parity relationship, where the value of the put option is in turn related to value of the call option. So consider the first step, wherein we have to note down what all things are given. So remember that the current stock price is 1,500, which is nothing but S naught equals to 1,500. The European call option is with an exercise price. So X is nothing but 1,400. Yet the time to maturity is 90 days. And the R, which is risk-free interest rate, is given as 8%. And the standard deviation, which is associated with the underlying asset, in this case Reliance Industries, is found to be 60%. Now, the second step, which is associated with, is finding out the value of D1. Remember, D1, as we discussed, is nothing but the log of greater the spot price in relation to the exercise price, the value of the call option or the value of the D1 will be higher, which is nothing but in terms of the weightage as of now. And at the same time, we will be able to consider the risk-free rate plus the variance which is associated divided by the standard deviation. Now, if we are able to substitute the value of the spot prices, which is 1,500, the exercise price is 1,400, risk-free rate of interest is 0.08, always consider the decimal values. And then the variance is given as 0.6, standard deviation is given as 0.6, and the variance will be 0.6 whole square, and the time period is nothing but 90 days. So 90 days divided by 365. So the D1 value will be nothing but 0.4468. Similarly, the value of the D2 will be nothing but D1 minus the standard deviation into root T, which will be nothing but equals to 0.1488. Remember, we are interested in the value of ND1 as well as ND2, which will be calculated using normal distribution tables. Since the value of the D1 as well as D2 are found to be positive in nature, we will first look into the table of the normal distribution table where the Z values are positive in nature. So since the first one, if the value of ND1 is found to be 0.4468, what we'll do now is the first two decimals which are there, we'll try to split it, and the rest two decimals which are there from the third as well as the fourth decimal place value which will be there, we will be considering it separately. So first one, the from the table, the value that is associated with 0.44 can be found out at the intersection of the table, wherein the row is nothing but 0.4, the second decimal is nothing but 4. So 0.44, the intersection cell will be nothing but 0.6700. This is what we have noted down. When it comes to the third decimal and in terms of the fourth decimal, which is 0.68. Remember, since we are trying to find out the value which is associated here, we will go with the concept of interpolation, wherein we will be able to say that this value of 0.0068 lies somewhere between 0.45 and 0.44. And for that reason, what we'll do is we'll consider this as 0.68 into the value that is associated with 0.45 is nothing but 0.6736, and the value that is associated with 0.44 is nothing but 0.6700. So 0.6736 minus 0.6700, you will be able to get some value that multiplied with 0.68 will give us the value of 0.0024. So if we add this 0.0024 to 0.67, we get the weightage that is associated with the spot price, which is nothing but ND1 is 0.6724. Similarly, when we go for calculating the value of ND2, we know that the ND2 value is nothing but D2 value is 0.1488. So the value of ND2 will be nothing but 0.14 is nothing but the intersection of the row with 0.1 with the column which is 0.04. The value is 0.5557. And then since we have to find out the value of the third decimal and the fourth decimal, we will be using the interpolation method where we assume that this value will be somewhere between the 0.15 value and 0.14 value. So we will try to deduct 0.5596 with 0.5557, which we will be able to get overall as 0.5592. So once you have got the value of ND1 as well as the ND2, what we'll do is we will substitute this value of ND1 as well as ND2 into our call option equation, which is nothing but the spot price minus the discounted value of the exercise price. ND1 is always associated with spot price, ND2 is always associated with the discounted value of the exercise price. So if the spot price is given as 1500, exercise price is given as 1400, and if we substitute the value of ND1 as well as ND2 into the equation, we will be able to get the value of the call option as 241.01. Now, this is the amount of premium which has to be paid by the buyer of the call option. Now, when it comes to calculating the value of the put option, remember in the formula of the put option, we have N minus D1 and N minus D2. So we should be able to calculate the negative values which are associated with the ND1, negative values. So we will consider the standard normal curve areas where the Z values which are there are negative in nature. So the first one, considering the value of negative 0.4468. So we will be considering first, we will be considering the value which is at the intersection of negative 0.4 and the column is nothing but 0.04, and the value that we will be able to get is 0.3300. And since this 0.68 which is there, we need to calculate this value. Remember, since we are going with minus D1, when we consider the formula here also, we will be always considering first the value of 0.44 and then the value of 0.45. So if I consider the intersection of the value, if I consider the intersection of negative 0.45 and an intersection of negative 0.44, the value that I will be able to get is 0.3300 and 0.3264. So similarly, if I have to consider the value of n minus t2, it is nothing but n minus 0.1488, which can be further divided into 2 decimals and 4 decimals. So n of negative 0.14 is nothing but the intersection of negative 0. Is nothing but negative 0.14, with the value comes to 0.4443, and for the third and the fourth decimal, we will be considering the values which is in between negative 0.14 and negative 0.15. So if we consider that, the negative 0.15 value comes to 0.4404, and the value associated with negative 0.14 is 0.4443. So if we multiply the difference with 0.88 and then subtract it with 0.4443, the value that we'll be getting for n minus d2 will be 0.4409. So once we have calculated the value of n minus d1 and n minus d2, we can substitute this in the Black-Scholes option model, wherein the value of the put option is nothing but exercise price minus the spot price, where we are considering the discounted value of the exercise price. And always remember, D1 is always associated with S0, but since we are calculating it for the put option, it will be N minus D1. Exercise price, we will be associating N minus D2 with the discounted value of the exercise price. So if we substitute all the values, we will be able to get the value of the put option equals to 113.82 per share. Now, there is another way in which the put option value can be calculated, that is using the put call parity relationship. We know that according to the put call parity relationship, when discount dividend is not provided, the value of the put option is nothing but value of the call option minus the spot price plus the value of discounted value of the exercise price, and the value of the put option we will be able to get it as 113.66. Now just remember, when dividend amount is expected to be paid on the stock or several stock within an index, we will be if we expect the amount of dividend is converted into the present value using the following equation, where we are considering the discounted value of all the dividends that is paid by several stocks within the index, and this adjusted spot rate which is there will be used for further calculations.